For this problem, we have a tank with a height of 10 feet. The area of every cross-section is given by a function a, where a of h is measured in square feet. The function a is told to us to be continuous and decreasing as h increases, and we can see some selected values of the a of h function given in the table above. The first problem asks us to use a left Riemann sum with 3 subintervals indicated by the data to approximate the volume of the tank. Okay, so if we want to calculate the volume, we'll need to integrate from 0 to 10 the a of h function with respect to h, because this will give me the area and this will give me the height. Now we're only given a few values, some discrete values here, so we'll have to approximate this with a Riemann sum, and they want us to do a left Riemann sum. So for that purpose, we'll take the length of the first subinterval, which is 2, and multiply it by the area at the left endpoint, which is 50.3. On the next interval, from 2 to 5, that is 3, and its area at the left endpoint is 14.4. And then from 5 to 10 is, of course, a height of 10, and its area at that left endpoint is 6.5. So we now need to add these up to, let's see, we're going to put this so I can see it, 2 times 50.3 plus 3 times 14.4 plus 5 times 6.5 yields 176.3. And since we were adding up square feet multiplied by feet, we are getting cubic feet. Not much of a shock, right? Because we were expecting to get a volume out of this problem. So there's the answer to part A. Okay, moving on to part B. Is this approximation overestimating or underestimating the volume of the tank? Well, remember we were told that A is a decreasing function. So if you have a decreasing function and you're using a left Riemann sum on the decreasing function, you can see that your rectangles are overestimating the truth. So we would say here that this is an overestimate. It is an overestimate since the a of h is decreasing. So a decreasing function is going to be overestimated by left endpoints. Okay, moving on to part C. C now gives us a algebraic or a formula for the actual area. Right? The area of the horizontal cross-section at height h is given by this particular function. So again, we still want to find the volume, but the volume will be found from the integral from 0 to 10 of the f of h function that is provided with respect to h. But now instead of having to estimate like we did in part A, we can now actually find the integral. So I'll go math 9, and we'll add up from 0 to 10 the function that is provided, which is 50.3 over e to the 0.2x plus x with respect to x. This gives us an answer of 101.325. So this is approximately 101.325, and the units are still cubic feet because you're adding up square feet multiplied by feet, and also because this is just a volume problem. Okay, 101. Notice this is a truth which was lower than the 176.3, so it's consistent with 176.3 being an overestimate. Okay, last problem, the related rate problem now. So this one says that D says that water is being pumped into the tank, and when the height of the water is 5 feet, the height is increasing at the rate of 0.26 foot per minute. Using the model from part C, find the rate at which the volume of the water is changing with respect to time when the height of the water happens to be 5 feet. Okay, so we want to find the rate at which the volume is changing with respect to time. So we want to find dV dt, right? We want to find dV dt. And we want to find this at h equals 5. So if we want to find the derivative of v with respect to time at h equals 5, let's take the derivative of the volume with respect to h, and we'll multiply that by the derivative of the height with respect to time. So this is the chain rule, right? All we're doing here is the chain rule. So in part C, we were told that the v is equal to the integral from 0 to h of f of x, or of f of x dx, to use a generic variable, right? That would be the v of h. So if we want to know what is the derivative of v with respect to h at h equals 5, that would simply be the derivative of this, which is just f of x, evaluated at, f of h at h equals 5. So that would just be f of 5. So in other words, this part right here is just f of 5. Now dh dt, the dh dt is given up here because it says that the height is increasing at the rate of 0.26 feet per minute. So the dh dt is 0.26. So in other words, all this problem really wants us to find is f of 5 and multiply it by 0.26. So let's find f of 5. Alpha 50.3 divided by e to the 0.2 times 5 plus 5. This gives us the f of 5, and now we'll multiply that by 0.26, and that yields an answer of 1.694. 1.694. This is a rate of change for the volume with respect to time, so our units here would be cubic feet per time unit, which in this problem is per minute. So that's going to be our final answer, 1.694 cubic feet per minute.